So in today's video we will start learning a little bit about factoring polynomials, and in particular this video will address the technique called factoring by grouping. And just in case you've forgotten what we mean when we talk about factoring, we can look at what we had back in Chapter 5 with quadratics. We've got this right here in standard form, and if we were to write it in factored form we would write it as x plus 2 times x plus 1. Where our factored form always has just a number of things multiplied together, and this is really helpful because it lets us know that, okay, the zeros of this, the x-intercepts of this quadratic equation are -2 and -1. So that's why it would be useful to us to be able to factor polynomials in general. Okay, but that was just a regular example to remind us what factoring means. That was not factoring by grouping, so we'll get rid of that and go into factoring by grouping. So this polynomial right here is an ideal candidate for factoring by grouping. One of the things that should tip you off that this is a good one for factoring by grouping is that this is a polynomial with 4 terms. So 4-term polynomials can often be factored by grouping. And the way we do this is we sort of look at the polynomial in 2 chunks here. And we look in the first chunk and we say, what's common between x cubed and -4x squared? Well, there's an x squared in common, so we're going to factor that out of the first pair of terms, and then we get x squared times x minus 4, plus, then we have to say what's common between the terms in the second portion, x and -4. Well, not really anything, just 1, and we get times x minus 4. So that's our first step in factoring by grouping, and this is really great because we notice that we've got an x minus 4 and an x minus 4. So the way we can rewrite this then is that this is x squared plus 1 times x minus 4. And that's what we get when we factored that original polynomial with the grouping technique. Now this step from here down to here is confusing for a few people. So let's just take a look at why this works. Well, if we look at this factored form of the polynomial, and we tried to multiply it out, we're not going to do it with FOILing. We're actually going to look at doing this really just with the distributive property. We're going to say that, okay, this should be the same as x squared times this whole quantity plus 1 times this whole quantity. So if we were to multiply that out with distribution, we'd get x squared times x minus 4 plus 1 times x minus 4. Which is exactly what we had right up here. So that's why factoring by grouping works for us. And we'll go through a couple more examples of this. So here's a new problem that we can look at for factoring by grouping. Again, we notice there are 4 terms, so we should be thinking maybe factoring by grouping is a possibility. And we split into 2 pieces. And we say, okay, what's in common between the 2 terms in the first piece? Well, each has an 8 and each has an x squared, so we get 8x squared times, okay, that's x minus 8, plus, okay, what's in common between x and -8? Well, nothing, except we can say it's multiplied by 1, so 1 times x minus 8. And now to complete our factoring by grouping, we will have 8x squared plus 1 times x minus 8. Now, let's get back to the question briefly of what is this good for? Well, this is good for telling us about x-intercepts of the polynomial. Certainly we look at this factor here and we should be able to say that there's a factor, or there's a x-intercept of 8. If we look at this one, well, we'd have to use our quadratic equation techniques to solve this one. Maybe quadratic formula if that's easy for you, or we could just say, okay, 8x squared plus 1 equals 0. 8x squared equals -1, x squared equals -1/8. And we take the square root to find those 2 remaining x-intercepts. Well, we can't do it because we can't square root a negative number. So the only x-intercept for this polynomial would be x equals 8. Don't worry about that too much for now. We'll get to that a little bit later, but I just wanted to point out why this is useful to us. So here's one final example for us. We look at this and we split into 2 chunks where we've got 4 terms. Making sure I hold on to that minus sign for the second chunk. I look and I say, okay, x squared is common between the first terms, so it's x squared times x plus 5. And then what's in common in the second one is we've got a negative 4, so minus 4 times x plus 5. And so when we complete our factoring by grouping, we've got x squared minus 4 times x plus 5. And this one we can actually go a step further, because this term right here, we should be getting comfortable factoring something that looks like this. We need two numbers that add to 0 and multiply to negative 4. That's positive and negative 2. So we have x minus 2, x plus 2, times x plus 5. So this is really nice when we're able to finish factoring like this, because we know we've got x-intercepts of 2, negative 2, and negative 5. So we factored by grouping to get here, and to get here we just needed to factor a quadratic similarly to what we've done in Chapter 5. Now it turns out we can also use factoring by grouping to factor something like this, a quadratic where the lead coefficient is not 1, something we haven't really dealt with before. And again we're going to ask ourselves about two numbers that multiply to something and add to something. And what we will do is we will look at the leading coefficient and the constant, and we'll multiply them together and say our numbers are going to multiply to that product. Negative 5 times 3 is negative 15, and they will add to this middle coefficient right here, so they will add to negative 2. I want two numbers that multiply to negative 15 and add to negative 2. Those numbers are negative 5 and positive 3. So what that's going to allow me to do is it's actually going to let me rewrite my original polynomial in 4 terms, just like I said I always needed to factor by grouping. And I'm going to rewrite the polynomial as 3x squared minus 5x plus 3x minus 5. So you can see these are really just the same thing, because negative 5x plus 3x is negative 2x. And now I'm prepared to factor by grouping. And I will take a look at the first group and the second group. Say what's in common with the first? Well, I've got an x in common with the first. So I've got x times 3x minus 5. Plus, okay, what's in common with the second? Nothing except a 1, so we've got 1 times 3x minus 5. So now, when I finish the factoring by grouping, I've got x plus 1 times 3x minus 5. And if you want to make sure I didn't make any mistakes, you can always FOIL this back out and check to make sure that you get what we started with way back up here. And just to refresh our memory, if we had that this was equal to 0 all the way through, well now, when I get down here, I've got two numbers that multiply to 0. So I get x plus 1 equals 0, or 3x minus 5 equals 0. So I get x equals negative 1, or x equals 5/3. So a helpful technique for finding solutions to that top equation without using the quadratic formula. And we'll do one more example like that. So let's say we've got 5x squared plus 19x plus 12, and we want to factor this. We can factor by grouping by looking for two numbers that multiply to the product of the first and last coefficients. So multiply to 5 times 12, multiply to 60, and add to 19. Okay, my numbers then are 15 and 4. 15 times 4 is 60, 15 plus 4 is 19. So I can rewrite my original expression as 5x squared plus 15x plus 4x plus 12. So again, I look at this first group of terms, what's in common? 5x is common, and I'm left with x plus 3. Plus, what's in common to the second set? Well, 4 is in common, plus 4 times x plus 3. So my result then is 5x plus 4 times x plus 3. And we have again factored by grouping, and again you can check by foiling. Now, what if we get to this step right here, and we find out that factoring by grouping doesn't work? Well, let's see what happens if I did these numbers in the opposite order. So let's say that I now know still that my numbers are 15 and 4, but instead I write 5x squared plus 4x plus 15x plus 12, which it's true that both of these lines are the same because 4x plus 15x gives me my 19x. And now I go and I say, okay, let's try to factor by grouping. Let's look here. And, okay, what's in common? An x. So I'm left with 5x plus 4. And what's in common here? I've got a 3 in common. So we've got 3 times 5x plus 4. And hey, what do you know? It didn't even matter that I switched the order. So I've got x plus 3 left times 5x plus 4. And I've factored just the same as I had when I had the 4x and the 15x in the opposite order. So, no problem there. So these will be the two types of problems that you'll see on your homework, or on your work that I'm going to assign for class tomorrow. But I just want to give one last example where factoring by grouping does not work, so that you can see what that looks like. So here we have a polynomial, 4 terms, so we should be thinking factoring by grouping. And we look at our first 2 terms. One thing I forgot to mention until this moment, it needs to be in standard form for us to make sure that this is going to work out nicely for us. So as you notice, I've got my cubed term, my squared term, my x term, and my constant. And I look and I go, okay, I'm going to factor by grouping. What's in common between the first two? Well, x squared times 2x minus 7, plus what's in common for the second group? Just a 4. So I've got 4 times x plus 2. So I've tried to factor by grouping, and how do I know it doesn't work? Well, these two things aren't the same. Those have to be the same for me to proceed with my next step in factoring by grouping. So if I wanted to find a way to factor this, I'm going to have to find another way. So no factoring by grouping when what's in parentheses does not match between the first and second groups. So that's all we have on factoring by grouping, and I will give you a couple problems to prepare for class tomorrow. So here are the 3 problems I'd like you to look at for class tomorrow. The first 2 should be straightforward factoring by grouping. The second one is that quadratic factoring by grouping, where you're going to have to look for 2 numbers that multiply to 4 times 3 and add to negative 8. And the other additional wrinkle in the third problem is I say it's equal to 0. So you got to start by factoring with factoring by grouping, but then I want to know what x is equal to in the end. So I will see you in class tomorrow.